This is chapter 23, problem number 36. The problem reads, a resonant frequency of an RCL circuit is 1.3 kilohertz and the value of its inductance is 7 millihenry. What is the resonant frequency in kilohertz when the value of the inductance is 1.5 millihertz? Alright, so first things first, I listed what was given in the problem. Here we have our resonant frequency, which is initially given as 1.3 kilohertz. We have the value of our first inductance, which is 70 millihertz, and the value of our second inductance, which is 1.5 millihertz. The equation we need to solve this problem is the resonant frequency equation, which is F naught equals 1 over 2 pi times the square root of LC. But I have here's the subscripts LC, L and C, L1 and C1, as well as F naught 1. F naught 1, just to keep them straight. But what we're ultimately going to be solving for in this case is our capacitance, so we can go back and actually plug it back into the F naught equation with our L2 value to attain the resonant frequency at 1.5 millihertz. But as you see here, I started the process by simply beginning to isolate the square root of LC with that term so we can get our capacitance from it. I simply multiplied each side by square root of LC and divided by F naught 1 to get me to this point. After that, I square both sides, so you're left with LC equals 1 over 2 pi F naught squared. And then moving on from there, I divided both sides by our inductance, which is L1 or L. So we're left with C. And we get a C value of 2.14 times 10 to the negative 8th farad. After that, we go back and use the resonant frequency equation again, but this time we're just going to actually plug in our numbers using the L2 value this time, but using the same C value to attain our resonant frequency at this inductance. So you plug in your values and you attain a value of F naught of 28.1 kilohertz.